All right, guys, before we get started today, are there any questions on any of the assignments so far? Any questions over any of the homework assignments? Now, it's going to be essentially the same thing as yesterday. There's one small change, but the rest of it is the same. Now, one thing I will say with two of the problems on the homework yesterday, you will have to use the quadratic formula to find the solutions, because the constant term for two of them is going to be e to an exponent, e to the fourth and e to the fifth for two of the problems. So we have to actually use the quadratic formula because we can't factor, since e to the fifth and e to the fourth are not nice numbers. That's fine. So you have to use quadratic formula for those to get the solutions. So if you do have questions, please ask. We can go over those if we need to. Now, the last section of chapter 6 is inequalities, solving logarithm and exponential equations, or not equations, inequalities, solving exponential and logarithmic inequalities. Now, with exponentials, and the first few that we'll look at and one later, with exponentials, we don't have to worry about restrictions. So if I look at the graph of 3 to the x, we get this here. Any value of x can work in an exponent. We can have positives, we can have negatives, we can have irrational numbers. All of them will work. That is not the same with logarithms. So if we look at log, so math, log base 3 of x, and we hit graph. Well, at the graph, we can see it starts at the y-axis. So the smallest value of x that we can have for log base 3 of x is 0. We can't actually have a value for 0, but they're going to start right after it. And if we look at the table, when x is 0, for the one in red, we have an error. We don't actually have a solution for it. So what's inside the logarithm has to be greater than or equal to 0. What's inside has to be greater than or equal to 0. So when we get to logarithms, we will have some restrictions we have to apply. But we're going to look at these here first. So our first equation, 3 to the x is greater than 20. Now, yesterday, if we were solving this here, the first thing we would do is what? Apply base. Guys, so log base 3 to both sides. Right, so if a log doesn't have a base written, it's understood to be 10. Now, here, we have log base 3 of 3. Well, this reduces to, just leaving us with x, is less than log base 3 of 20. So we can use the graphing calculator. Go math. Log base 3 of 20 is 2.72683. Well, we're going to round to the nearest third decimal place. So yes. So x is greater than or less than 2.727. So any value of x that's less than 2.727 will give us a value that's less than 20. Yes, sir. So the main thing with this here is the base, because log base 3 of 3 is 1. So if it had been 4, we wouldn't use log base 3. We'd be using log base 4, because it would simplify out. And one of the properties of logarithms is that log of m to the n is the same as n times log of m. So we can move the exponent out front. That's why we use logarithms. So if it's not written, it's understood to be 10. Just like with x, our final answer is understood to be to the first power, or the number in front of it's 1. So it's one of those where it's just an understood rule. If it's not written, it's understood to be base 10, and we can go from there. ln, the base is understood to be e, but we don't write it. Any questions on this first one here? So this is problem number 9. E to the x is less than 2. So here the base is 10e, so we're going to apply ln, because ln's base is understood to be e. Because if it's e, we use ln. If it had been 10 to the x, we would indeed just use log. All right, guys, let's focus in. Then we would move the x to the front, really telling us that we have x ln of e is less than the natural log of, but the natural log of e is telling us x is less than the natural log of 2. Because it does work out that the natural log of e to the first power is, so we have 1 times x, which is just x. Now at this point here, we can take ln of 2. Nice. Yes, so 0, x is less than 0.693. With exponentials, the only thing that we could have that's a catch is if we multiply or divide by a negative, then we have to switch the inequality sign. But that's true with any equalities. If it does come up, it's one thing we do need to pay attention to, but that's nothing new. Because when we did inequalities the first time in Algebra 1, we had that. So that's nothing that's changed. We just do this here. Questions on any of this here? Are you ready for the next one? Again, it's greater than 3. So this time, what are we going to apply to both sides? And since the base is 10, the logarithm's base that we need would be, now log, L-O-G's base, if we don't write a number, is understood to be 10. So we can just write it as log. Now the 2x minus 6 will move to the front. Log of 10 is greater than log of 3. Now log of 10 is going to be 1 times 1. Just 2x minus 6 is greater than log of 3. Now, one thing we do need to be careful is that log of 3 is contained in there. We can't add anything to the 3. We can't subtract anything from it unless we have another log with the same base. We will, as long as x is by itself at this point. Guys, so we will divide by 2 eventually, but I would also move the 6 first. Log of 3 plus 6. So we can't add the 6 and 3 together, guys. Then we would divide by 2. So we can't add the 6 and 3 together because the 3 is contained within the log. Now lastly, we'll divide by 2. Minus x is greater than log of 3 plus 6 divided by. Now, since it's a common log, the base is 10, we can plug it in either calculator. So I can use the 30xs, dot fraction log of 3 plus 6 over 2. And with the logs, when we type this in, we need to make sure that parentheses is closed. Yes. 3.239. And that's it. Questions on any of this here? Any questions on anything we've done so far? Yes. We can't divide with the 3. So I can't say log of 3 divided by 2, but we can divide log by a number. as long as you don't translate this into, say, log of 3 plus 6 divided by 2, you're fine. Because that and what we have here, these are not the same. Does that make sense? Any other questions on this here? Are you ready for the next one? Now what we're looking at now is logarithms, solving logarithms. Now what's inside the log, in this case x, cannot have a value that is equal to 0 or less than it. Because here we have to say what's inside the log, which is just x, has to be greater than 0. Now, if we had something in there more than that, say 2x plus 1, we'd actually have a little more to it. But here, we're just saying x has to be greater than 0. Now, this may or may not come into play. It depends on what the solutions is or are. Any questions on the restrictions before we go about solving this here? So now we're going to do kind of the opposite of what we did before. On the first view that we did, we applied a log to both sides to get it to simplify. Here, we're going to add a base. So the base of this log is, so we're going to put both sides to the base of 10. Because 10 to the log base 10 will, it's not leaving us with x that are equal to 10 to the second, which is 100. So here we're saying x is less than or equal to 100. X is by itself, so we did solve this here, yes? Now, we do need to look back at the restriction. X is greater than 0, yes? Is 0 less than or equal to 100? 0 less than 100. Yeah. If these restrictions are a part of our solution, we have to add back in that restriction to it. So we have to tell it that, yes, x is less than or equal to 100, but x has to be greater than 0. And that's it. Now, if it had said the other direction, if it said x is greater than or equal to 100, is 0 greater than 100? 0 is not greater than 100, so that would be it. Because if the restrictions are not included in the solution set, we don't have to include them. But if they are, we do have to add that restriction to it. But that's it. Questions on any of this here? So with a lot of these here with logarithms, it's good to start out with the restrictions, solve it, and then see if they're included. Because sometimes they will be, and sometimes they won't. Let's look at the next one. Log of x plus 9 is less than 45. I will put, it will. Now, I will put parentheses, especially on the review and test, around what's inside the log. Now, according to the math textbooks and most books, if they don't put parentheses around the number, they are assuming you understand that the plus 9 is not included. If it plus 9 is outside of the log. The only way we would know for sure that it was is they would tell us log parentheses x plus 9 close parentheses that it is. It's not nice. I will put parentheses around what's inside the log every single time, even if it is just the variable x. So on the test and review, it will look like this for the same problem. So the base would be 10, but before we can do that, we need the logarithm by its. Yes. Now we'll get back to the restrictions here in a minute. We'll go on and finish this first. So we have log of x is less than our next step would be 2. Put both sides. Ten to the 36. How many zeros will 10 to the 36 have? It would be 36 zeros. Yeah. Yes. 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36 would be that number. Yeah. If it's 1 undectillion, I believe, if I did the calculations right. So, with this here, if the answers on the homework go more than 6 digits, leave it in exponential form. Like that? Yes. Now, we didn't talk about the restrictions, but what's inside the logarithm is just x, and this needs to be greater than 0. So what that's telling us is that we do need to add the fact that 0 is less than x is less than 10 to the 36th. With exponentials? Okay. Any other questions on this here? Let's look at this one here. 2 ln of x minus 1. So the x is the only thing inside the natural log. So we don't have any other restrictions to that. Now,
we have to get that by itself.
So yeah, so we'll get it by itself. I'm going to go on and do the restrictions because luckily for these here, the restrictions aren't too bad. It's just x has to be greater than 0. Okay. So 2 times ln. So the first thing we can do is add 1 minus 2 ln of x is greater than 5. Okay. Then what would we do next? Because we have to get the natural log by itself. So we added 1, and then we divide by 2 to tell us that ln of x is greater than 5/2. I'm going to leave it as 5/2. We can put 2.5, either one. I'm just going to leave it as a fraction. If it reduced nicely, I would reduce it, but we'll leave it as 5/2, mainly because our next step to reduce or get rid of the ln, we have to put both sides to the base of e. These will cancel, guys, telling us x is greater than e to the 5/2. Now at this point here, we could plug this into the calculator. We can say second e to the 5/2 is 12.182. Any questions on how we got to this point here? So x is greater than this, yes? Our restriction was that x has to be greater than, is 0 greater than 12.182? No. So for this here, that's the answer, because we don't have 0 included as part of the answer. It's not a true in that statement. We don't have to include it, because every solution will work for this here. Any questions on any of this here? Second ln. And they put them together because to undo ln we use e, to undo e we use ln. So they put those together. Any questions on anything we've done so far? Do we need to see another example of exponentials? Now, let's look at this one here. We'll do, I was planning on doing this, one of these and then one more with logs, and then we'll be done for today. Now the first thing we need to do is get e by itself. So we can, these will cancel. E to the negative x is greater than 9. We would, guys, apply ln to both sides. Because ln of e is 1, so it simplifies out to 1 times negative x, which is negative x. Now is x by itself. So we can divide both sides by negative 1. Negative x, guys, divided by negative 1 is x. And this would be negative ln of, but we have to switch the inequality sign because we divided by a negative, telling us x is less than ln of 9, negative 9. And if we type this in, negative ln of 9, we get negative 2.197. Now, because it is an exponential, not a logarithmic, that's fine. So this here it can, because if it's the starting variables in an exponent, not inside a logarithm, it could be positive, it could be negative, it can be 0, it can be anything, any value of x, if x starts in an exponent. If x starts in a logarithm, it has to be greater than 0. So we'll look at this one here. This one really needs another set of parentheses because the 2x minus 3 is to the third. Now again, let's find the restriction first. So with natural logs, what's inside the logarithm has to be greater than 0. So here we're saying that 2x minus 3 has to be greater than 0. Now at this point here, we can add 3 to both sides, telling us that 2x greater than 3, telling us x has to be greater than 3/2. So if x is greater than 3/2, it's going to work. If it's less than that, so we're just looking at what's going to make this here be 0. So just the restrictions. We could have added it to both sides, and we would take the cubed root of 0, which is still 0. Now, here, guys, this last problem, so let's focus in. We can use our properties of logarithms. And the first is going to be moving the ln to the front. Because we could have applied e first, but that's going to leave us with a third power, which means I'm going to have to take a cubed root. If they were being added, but since they're being multiplied, we would divide by 3, telling us the natural log of 3 is greater than 2. Now, since the logarithm is by itself, we would put both sides to the base of. These would cancel, telling us that 2x is greater than e to the second power. Now at this point here, we just need to get x by itself, so we can. Yes. Telling us that 2x is greater than e squared plus 3. And last but not least, telling us that x is greater than e squared plus 3 over yes. Now it'll be good to put it in the calculator to see exactly what this value is. E squared plus 3 all over 2 is 5.195. Well, our restriction said that x had to be greater than 3/2 or 1.5. But since it is, this would be the solution. Questions on any of these here? And that's it. And that is all we're going to do today.